So welcome everyone to my channel. Myself, Professor Pratik Prakash Kare, your tutor, and we have started this new subject, that is engineering mechanics, and we have gone through the first lecture, that is introduction to the engineering mechanics, and we have seen the concept of force. Okay, some basic definitions of body, different parts of mechanics that we are going to study in this entire subject. And today, continuing to our previous lecture, we are going to see how to resolve the forces in their perpendicular components, and also some fundamental basic principles in the engineering mechanics on which this entire structure of mechanics is stood. Okay, so moving to the next. So how can we carry out the resolution of force? Resolution means to represent the given force into two mutually perpendicular components. So for that, consider any force P1 which is acting at an angle theta with respect to horizontal at any point. This is your P1 and it is inclined at theta degree with respect to horizontal. So we can represent the force. Then the P1 force can be also represented in its resolved components using basics of trigonometry. So this inclined force can be represented in its horizontal component as P1 cos theta and its vertical component as P1 sin theta using some basics of trigonometry. Okay, are you getting this point? Okay. Now I will just use this laser point to show you. Okay, this is all about the resolution of force. You can resolve this force P1 with respect to this horizontal and vertical component. Okay, instead of using this inclined force for analysis, you can use its components. Now if what happens if theta is given with respect to vertical? If theta is given with respect to vertical, then this component will be P1 cos theta and this one will be P1 sin theta. Just remember this one thing. Then fundamental principles. Okay, so there are 6 fundamental principles in the entire engineering mechanics. So the first one is the law of parallelogram or vector addition or forces addition law. Second one is the principle of transmissibility. Third one is Newton's first law of motion. Fourth one is Newton's second law of motion. Fifth one is Newton's third law of motion. And sixth one is Newton's law of gravitation. Now we will see one by one how these fundamental principles are derived and how we can use them during the entire course. So the first theorem, that is the parallelogram law of forces. This law is also called as the Thevenin's law of forces or Thevenin's law of combination of forces. This may ask in your MCQ type questions. Okay, so this is the important line. Now what is the statement of this law? The statement of this law is if the two forces acting simultaneously at any point, they can be represented in both, that is magnitude and direction, by the adjacent side of the parallelogram drawn from a point, then the resultant vector is represented both in magnitude and direction by the diagonal of the parallelogram passing through that point. Okay, try to understand this statement. If you are not getting the statement right now, you will get it. Don't worry about that. Now for this, we have to consider this particular force system. Consider particle A that is acted upon by P1 and P2 forces which are separated by some theta angle in between them. Now, as the statement says, now according to this parallelogram law of forces, P1 and P2 forces acting on the particle A simultaneously, the AC will be the resultant of this system. Okay, so this red one, AC, is represented as resultant of these two. Resultant means the representer of all the forces given in the system which will produce same effect produced by the all sub all forces. Means whatever the effect on this particle that will be produced by this P1 and P2, same effect will be produced by this AC force, that is R, that is resultant force. That is the definition of resultant. We are going to see this resultant in very detail in our next lectures. So AC will be the resultant. Now if I complete this diagram by this dotted line BC, if I join BC and DC, where BC is parallel to AD and DC is parallel to AB, so this will complete one parallelogram. So this in this parallelogram, so this P1 and P2 are the adjacent side of this parallelogram. Yes, as per this statement. Now you should get this statement. So now extend this D point with some dotted line to D dash and draw one perpendicular CD on this line. Now we will get one we will get one triangle over here, that is D dash C. Okay, so in this the inclination will remain same. P2's inclination with respect to horizontal, that is theta. Now we can define this component, that is DD dash, as P2 cos theta and CD dash as P2 sin theta using basics of trigonometry. So from Pythagoras theorem in triangle A, D dash and C, this entire triangle I am taking. So AC square, that is diagonal square, is always sum of side square, that is AD dash square plus CD dash square. Now R square equal to, what is AD dash? It is P1 plus P2 cos theta square plus P2 sin theta bracket square. Now solving this equation, it will give you R1 square, opening this bracket, A plus B bracket square, A square plus twice AB plus B square. So P1 square plus 2P1 P2 cos theta plus P2 square cos square theta plus P2 sin square theta. Yes, P2 sin theta bracket square. Okay. So after solving this particular equation, we will get this. Okay, and from this one we will get cos square theta plus sin square theta. It is a trigonometric identity, so it is always equal to 1. So from equation 1 you will get value of resultant using law of parallelogram like this, under root of P1 square plus 2P1 P2 cos theta plus P2 square. And if we assume one angle phi, it is the angle between the resultant R and the force P1. Then by using trigonometry in A D dash C triangle, we will get tan phi equal to D dash C upon AD dash, that is P2 sin theta upon P1 plus P2 cos theta. Okay, so these are two important formulas, that is how to find resultant and how to find this inclination with respect to the horizontal P1 force. Okay, now important points to be remembered for this particular law of parallelogram. If we put theta equal to 0, it will give you resultant equal to P1 plus P2. It means on particle both forces are acting in a same line and in same direction, because cos 0 is 1. Now if we put theta equal to 90, cos 90 is 0, therefore it will give you root of P1 square plus P2 square, the resultant's value, and this means your two forces are acting perpendicular to each other at the point A. Now if we put theta equal to 180 degree, that is when two forces acts along same line but in opposite direction, and in this case resultant's value will be P1 minus P2, assuming that P1 is greater than P2 here, since cos 180 is a minus 1. So you will get some standard result over here, and this is very important as per your MPSC preliminary examination, MES. Okay. Now second principle is principle of transmissibility. So in this principle of transmissibility, it states that the force can be shifted anywhere on the line of action of the force without changing its effect. So there are two criteria for shifting of force. First criteria is to shift the force in same line of action, and second criteria is to shift the force in its parallel line of action. So first criteria, please look at here. Consider this yellow body on which this P1 force is acting. So this dotted line is representing its line of action. Now if I want to shift this P1 force from this bottom part to this top part, I can shift this anywhere in this line of action, and it can be said that its effect will not change. Okay. Similarly, whenever you will shift your force, that is given force, in some parallel line of action, In that case, it will change its effect. How? Please look at here. Consider this P1 force is acting on this blue body. Yes, this is second. Please make this correction. P1 force is acting on this body at this point, and this is the line of action. Now if I want to shift this P1 force into this new line of action, which is at some distance x and which is parallel to the existing line of action, then we can shift this force P1 here with P1 into its rotational effect, that is force into this is perpendicular distance, that is P1 into x. So it is a rotational effect also shifting with the force when we shift the force in parallel line of action. Okay, now third and important principle is the Newton's first law of motion. So statement for this Newton's first law of motion is every object will be in a state of rest or in a uniform motion unless and until forces applied on it. What exactly do you understand by this statement? It will give you idea about the presence of force. Okay, this particular statement of Newton's will give you information about the presence of force. Okay, Newton's second law of motion, what is the statement? There are different statements for this second law, okay, with respect to the different authors. So I have given some one or two statements over here which are, I think, which can be easily remembered to you. So the first statement is the amount of acceleration of a body is directly proportional to the force causing acceleration and inversely proportional to the mass of the body. It is implemented in our day-to-day life also. Okay, if anyone pushes you with the force, your acceleration is directly proportional to that push, means that force. And if you are having less mass or heavy mass, according to that your acceleration will get changed, means that acceleration will be inversely proportional to your mass. If your mass is higher, your acceleration will be low, means you will get less acceleration with the same force, and if your mass is less, with the same force you will get a better acceleration. Now the second statement, which is very popular, that is the rate of change of momentum with time of a body is equal in magnitude and direction of the force imposed on it. So what do you mean by momentum? Momentum is nothing but mass into velocity, and rate of change of momentum means m dv by dt, and dv by dt is our acceleration. So mass into acceleration we will get from here also. So this is the Newton's second law. So this particular second law of Newton's gives you the quantity of force. First law states that presence of force. Second law gives the information about the quantity of force. You can quantify this force. Now Newton's third law of motion is every action has equal and opposite reaction. Okay, so you always know this as a science student. You should know this. Okay, now sixth principle is the Newton's law of gravitation. Now this is important and new to everyone. So its statement is like when two bodies are attracted towards each other along the line connecting them with a force F whose magnitude is directly proportional to the product of their masses and inversely proportional to the square of distance between them. Consider these two different bodies of different masses m1 and m2, and this both the masses or both the bodies are attracted towards each other by this p1 p2 equal to f force, then and they are separated by some x distance, then this p1 equal to p2 equal to f, that is force of attraction, is given by g into m1 into n2, that is product of masses, and upon x square, that is the distance between these two bodies, where g is the gravitational constant. Now units of measurement, generally there are three units of measurement: centimeter, gram, second unit; meter, kilo, second unit; and there is one SI system. So generally nowadays we adopt SI system for this unit measurement. There are three fundamental units in which all the units are from which all the different units are derived: mass, length, and time. Thank you so much.